Natural disturbances such as wind, wildfire, pests and diseases are important factors that are changing our forests. Disturbances can result in large areas with dead trees and damaged wood. However, disturbances can also promote tree regeneration and increase species diversity and thereby provide opportunities to fight climate change. In this second episode of the Forest Chat podcast, we will cover raging wildfires and savage storms, as well as tempests and timber harvests. My name is Hans Verkerk, Chief Scientist at the European Forest Institute and Coordinator of the ForestPaths project. I am talking today with Alba Viana-Soto of the Technical University of Munich, and she has developed a next-generation Forest Disturbance Atlas. Welcome, Alba, in this podcast. Can you explain why monitoring forest disturbances is so important in Europe?
Forests in Europe have long played a vital role, providing essential services to society that span from being a carbon sink, but also providing services like timber production, water purification and regulation, etc. However, forests are under growing pressure. On the one hand, natural disturbances are increasing related to climate extreme events, for example, extreme large fires, also windstorms and viral outbreaks. But also on the side, there is a growing demand of good products, biomass production, etc. And this makes a lot of pressure and intensifies the use of the forests in Europe. As a result of all of this accumulation, the net carbon balance in Europe is declining. So in this context, it becomes really crucial to monitor forests in a more accurate, timely, and especially explicit, detailed way. Understanding better when, where, and how much forests are being lost or degraded is essential then for effective policymaking, for sustainable forest management, and for planning both afforestation but also restoration of degraded ecosystems. And this altogether is crucial to restoring and enhancing the climate mitigation potential of European forests towards keeping the track on the EU climate goals.
Yeah, so you're mentioning that forests are under pressure. Can you tell a little bit more than what this means in terms of disturbances? So how do disturbances add on the pressure to forest, and what disturbance do you mean?
Yeah, by disturbances we mean changes in the canopy of the forest. That means that you go to the forest and some trees are either dying or they are being removed. And this happens from natural circumstances like forest fires, but they can also happen by harvesting activities. For example, we make use of the wood of the forest and therefore we extract the trees from the forest. This combination, it was a stable dynamic so far, but with more climate extremes, forests are now suffering from more prolonged and extreme droughts. And this makes also or paves the road somehow to other biotic agents like viral outbreaks and other insects that are attacking the forest that were supposed to be in harvest and timber production at some point, but they are affected by natural disturbances. And this makes a lot of pressure because they are unprecedented, they are in a larger scale, and thus makes more intervention and management more difficult to address in a very large and continental scales.
Okay, so you mentioned fires, windstorm, pest diseases, and also harvest. Which of these is the most important in the European case?
Well, in terms of how much area is affected by those disturbances, harvest is still the, let's say, the disturbance that caused the most of the forest. Removals, this is roughly between 70–89%. The estimations fluctuate a little bit, but these are the ones that we can somehow control and make a clear action on them. But on the other side, there are all the other natural ones that they just come. We can not really predict beforehand. And this is also causing interactions with the harvesting activities because some plantations are being affected by natural disturbances. So what was supposed to be harvested sometimes is even before affected by fires, windstorms, or all their pest infestations. So they are all together really important. On the one side, the ones that we can predict a little bit more, and the other ones that are unprecedented, but also cause disturbances and losses on the unplanned and on the planned planet ones.
So humans are quite important in this context for the ones, I think, if I understand you correctly, as they are responsible for harvesting the trees, but perhaps then also indirectly by changing the composition of the forest in terms of species and forest structure that make the forest more vulnerable or prone to disturbances, right?
Yeah, exactly. We have long been playing a role on managing the forests, somehow making the distribution of the landscape much more complex, fragmented, but also more homogeneous in some areas when we have monospecific plantations, for example. And now we have this in Central Europe, for example, the large barbital outbreaks that are targeting a specific species. So this is really crucial how we think into the future. Also in the south, in the Mediterranean, where you also have a lot of productive pine plantations in some areas, as we saw in Portugal, for example, and those are being affected by forest fires. So really human intervention on how we manage the forests, how then we act as humans, for example, savage logging after barbital outbreaks or replanting after a forest fire, etc. All those kind of human actions also as a reaction to natural disturbances plays a crucial role.
Okay, very clear. So what is actually then included in the atlas that you developed?
Yeah, in the atlas we included information on both kind of disturbances. On the one side, we included the natural ones, although they may have an anthropogenic somehow origin because humans, we are also part of the climate change. But we separate fires, windstorms, and barbitals from harvesting activities. So we are somehow first identifying where those disturbances occur. That means when forests are dying or gone. And in a second step, we identify the most likely root cause. So we can see the savage log, but we identify that this savage log, for example, was done as a reaction to the barbital infestations. And this is the kind of information that we provide in our maps.
But how do you do that? I mean, a satellite, you use satellite imagery that gives you a picture of the state of the forest. How can you see that this is then a bark beetle, or if it's a harvester or wind? Like, how can you see this from the picture?
Yeah, this is really interesting because from the satellite perspective, now that we have this big opportunity, a lot of satellite missions going on, they have on board certain kind of sensors that they collect information on the energy that the surface of the Earth is reflecting. And particularly, we are interested in to see how the energy of the vegetation reflects and what is captured by the sensor. How this works is pretty simple. The vegetation, when you see with your eyes, if it's greener or is becoming orange or brownish, or the leaves are gone because there is some defoliation going on, this makes a difference on the energy that the forest reflects. So the sensor can capture those changes. And more interestingly is that those sensors can see beyond what human eyes can see, because they can record information in the infrared, we called in this range of the other light of a spectrum. So this is really sensitive to see early on how forests are declining or how forests are being stressed because they are exhibiting less photosynthetic activity, etc. So this is what the sensor can see. And if we put all together so many images, thousands of images across many months and years, altogether we can see the evolution somehow. So we can see how the forest was stable somehow and how this turns to a different state as soon as there is a change.
Yeah, so basically there are a bunch of pictures that you are checking. From the photo, you see a particular color being reflected, or not necessarily the color we see, but the color that the sensor sees. And out of that, you can see whether a tree is declining or has been removed out of this. But still out of this, so that you can just see if something was there and then it was not, or if it's not well. But how can you then see whether this is a storm or a bark beetle outbreak?
Yes, that's really interesting because it's actually not only the light or the energy that the vegetation reflects, as you said, but also the spatial configuration. When those kind of disturbances happen, let's start, for example, with fires. Fires ignite and they spread across the landscape depending on fuel, moisture, etc. So many characteristics. But eventually, when it's extinguished and it's done, they leave in the landscape a clear footprint that is quite heterogeneous. And it has been driven by wind and many other factors, but it's the shape of the patch. When you look at, for example, Google Maps and you see the geometric shapes of croplands, you will see, for example, for fires, a quite heterogeneous and sinuous shape of the landscape. And this, together with the spectral information that we get from this energy exchange with the sensor, we can identify as a fire, for example. With windstorms, on the other side, they usually behave geographically in a way that they leave linear features. So basically,
like wind gusts through the landscape.
Exactly. So it's pretty rare that you will see a fire with this shape, for example, but rather a windstorm, because it's just how atmospherically the circulation works. And then on the other side, for example, with the bark beetle outbreaks, it's quite sometimes difficult to distinguish from windstorms, not for the way they behave or how they spread and infest the different patches of trees. But at the end, what you have is a lot of standing dead wood, a lot of standing dead trees that with the wind, some are basically falling down, but they are still there and so on. So although the original cause is completely different than from winds, from the energy exchange with the sensor is not really clear. So windstorms and bark beetles are one of the most agents more difficult to distinguish, but still we are working on how to better differentiate those. And finally, with the harvesting, we do not have really good reference on harvesting, let's say, or not so many databases, but what we do know from the system is in a regular harvesting system, you will cut a little bit every year, but you will not cut all the landscape at once, as for example in a windstorm or in a fire that just gets to the forest and just affects a lot of area in once. With a harvesting system, you will cut a little bit, next year a little bit more, and next year a little bit more. And they usually leave in the landscape a footprint, pretty clear geometric shape because of the machinery and the strategies of extracting the wood. So it's more about a combination between the shape and the landscape metrics, the landscape configuration, plus the spectral and the energy information we get from the sensor. So it's quite geographic components on it.
Yeah, super interesting. So you combine information that you see with the sensor in terms of reflection, but you also combine information on the shape of the disturbance and do the attribution accordingly. Cool. So, but when I introduced you in the beginning, I also mentioned that it was a next generation forest disturbance atlas. I can have a feeling what is the next generation of this, but perhaps can you explain a bit what is meant with that? What is the next generation out in this forest atlas?
Yes, a good question. With all the new revolution of having more data, more AI, and so many new methods that are arising, all this next level, new generation and so on, I assume it gets a little bit confusing. But we did here, it was somehow next generation because we improved so many things. On the one side, we extended the time frame of disturbances that were before from other products, both in Europe and global, because they did mostly not extend beyond 2000s, because it's another generation of satellite missions. So we wanted to expand to the 20th century because most of the land use changes in Europe actually happened in the 20th century. And disturbances leave a footprint in the landscape, as I mentioned. So it's really interesting to see how this landscape evolved from the past to the present. Then on the other side, we applied now a machine learning algorithm that, without entering into so much detail, is more mathematical power somehow to distinguish many different details that we cannot even see by human eye or sensor, but all those numbers together makes it more accurate to distinguish more true disturbances. So we are now able to capture more disturbances that were not included in the previous maps. And then finally, with all this together, having annual maps from 1985 to up to date, we can have multiple disturbances. And this is something that was somehow overlooked before, because you can have a fire, then you can have natural regeneration or replanted the forest, and then more recently can be suffer a fire again. And then you have two basically disturbances in the same location that were missing before, because the map didn't extend before 2000s. And we have observed quite many of those, roughly 30% of the disturbances locations that we see in the landscape have actually had a disturbance before. And also not only with natural disturbances, but also with short rotation plantation systems, that you could have harvested an area and then replanted again, of course, because it's a productive forest, and then you cut it again, or is maybe affected by other kind of disturbance. But you need this long-term perspective to cover all those kind of interactions, and that was our main goal, to have this next generation of disturbances maps.
Okay, wow, very cool. You also said that you used AI, and I guess you do this for a reason. Can you tell a bit more what the technologies you used for this, and what are the main difficulties perhaps that you have come across when doing this? I have a feeling this was not done on a laptop, but in a bit more advanced way.
Yeah, I think maybe 7 years ago, or maybe not even 7, 10 or 5, it was not even thinkable that we could do that in a, let's say, standard server. So we need, of course, processing capacities to handle more than 100,000 images that we need to process on ourselves, and then processing those images, applying so many corrections, because of course there is noise from the atmosphere, etc. And then finding an algorithm that can handle detecting disturbances in a clear cut in Finland, but also a fire in Greece, and then barbital outbreaks in the middle of the Czech Republic. So it's a combination of having computational capacity that is nowadays possible, but also having this AI group of algorithms that they are really good at identifying patterns in space and time that we cannot, with a clear view or quick view on the images, you can identify some, but they are really good into going a step beyond and identify those patterns that can really generalize and identify among many other changes in the landscape the clear disturbances that we are targeting, or we are training the algorithm to detect those stand replacing or mostly stand replacing disturbances where we are included in the maps. So the more difficult part is, of course, doing a generalizable workflow that works everywhere, basically, and that we need to convert many teras of data to a little gigas, because at the end, the final user is going to need to terabytes, sorry.
Okay, sorry.
Good correction. Yeah, it's actually many terabytes, more than 50 terabytes of original data, that then once you process this data, it multiplies to 100 terabytes and it keeps increasing forever. So you need to really handle this in an efficient way to end with a map that is just a few gigas for the final user. So it's converting a lot to too little and really informative maps. This is the biggest challenge, I would say.
Okay, so this seems like quite massive calculations. So like now, I think you did it until 2023, but now we are in 2025. So if now new images would come available, how long it would take you to add a new year to the calculations?
Mm-hmm. It's a really good question that we were thinking through the process. It roughly takes up to 2 weeks to process everything if we use our maximum capacities in our servers. We usually take some more time, of course, to do some extra checks And we have already computed 24, is now in the final process of checking and evaluation the quality of the estimations. And what we plan, for example, for 25, now that we took enough time to also improve some stuff on the workflow, because it was the, okay, next generation, first version until 23, let's run 24, let's see how this performs. We have it now almost ready. And then for autumn, we plan to, after September, when the summer season ends, so to say, press a button and have all the runs also for 25. And it should take up to 2 or 3 weeks to compute from downloading the images from 25, processing them, then apply the algorithm to detect the disturbances, and then identify if it was either fire, wind, barbital, or harvest, and then create all the different, let's say, products for the different countries, because we aim to provide country-level data, although we process all in once, is to make it more manageable for the users.
Okay, so this goes very fast now, but I bet that it was not so fast to do the work before. So for whom is this atlas? For whom did you develop the atlas?
Well, this atlas was thought to be a living atlas, so that it can be, as we have discussed, in like being able to provide up-to-date maps. We are falling behind with 24, but we will update it soon. This was a lot of work, as you mentioned, and it took so long before. Now we make it light and faster, but this took some time. So it's thought to be used by many different groups of users, from researchers to policymakers to NGOs, etc. We aim it here to provide data that can be used for as a baseline, or somehow as a data being used by other kind of research. So you can use this data for bird tracking communities, diversity, etc. So we have been also involved in many different research from the wildlife interactions with disturbances, which is really interesting. Also, it's a quite important component for calculating the carbon budget. That is something that countries have to report, but then everyone has different methodologies. So to reconcile the carbon budget is also quite crucial to have the removals from the disturbances. And then beyond that, it's also thought to be used by people that do not necessarily are in the forestry sector directly, or do not have a good or deep, better say deep, knowledge on maps, remote sensing, and all those technicalities, but can just have a base to identify hotspots of certain activities happening. And I think this is for example, for NGOs or for policymakers to better know what has been going on in the last years, or maybe in the present year, around disturbances and forest. But of course, we are just one piece of the pipeline, or of the process. So from the development to the final user, we hope that we can also provide information that is useful for more communities.
Yeah, and I think especially the information that you can get from your atlas is the changes, right? Like you really see rapid changes in forest structures. It's not about showing how the forests look now, but actually how they are changing over time, and providing rapid and detailed information on those. I think this sounds all very interesting, and I would like to thank you also for your time to explain the atlas that you have developed. Where can we access it? How can we find the data behind your atlas, or the atlas itself?
Yeah, the atlas is a combination of different maps of different information that we have been mentioning here, and can be found in the Google Earth Engine platform as a set of maps that you can visualize, play, and zoom in. But you can also download them freely available in the Zenodo repository. There are all those links also in the research related, explaining further the methods, in case someone is interested to go in depth into the methods. It's also explained in a research paper.
Okay, perfect. Yeah, then I think you will have the links, and then we will make the links available from our show notes, so that people the listeners that would like to see your maps, they can actually access them. And with that, I would really like to thank you. I think this was very impressive work that you have done, and I really enjoyed listening to listening to you when you explained all the work that has been done. So, good job, very nicely done.
Thanks for inviting me. It's really interesting to exchange and to talk about forest disturbances in Europe.
Thank you, Alba, for your great and interesting work. Really, really impressive. A big thank you also to all the listeners. It was a pleasure to welcome you back to the second episode of our podcast series. You can find out more about ForestPaths through our website or our socials, and you can find details on that in our show notes. Take care, and until next time.